forces are not in the same direction? What if they're at angles to each other? Well, remember when we have forces that are acting at angles to each other, then we need to use vector component addition to add them. So let's say that you had F32 and F31, right? Now what this means is that F32 is the force of Q3 on 1, and F31 is the force of Q1 on Q3. So what we're going to do is we're going to think about this, right? If I want to find that net force, remember that I can resolve each F32 into its x and y, and I can resolve F31 into its x and y. I can write them in unit vector notation, or I can make a chart, either way. I'm going to write them in unit vector notation. So for example, notice that this is going to have a positive x and a negative y. So F31, for example, in unit vector notation is going to have some x component in the I direction, positive I direction, minus some y component in the j direction. And F32 is simply in the upward positive direction. So it has 0i and it has positive fy in the j direction. So if I want to find the net force, right, I can then add these two x components to find the I component or x component of the resultant. And then I can add these together, right? One's negative, one's positive, to figure out what the j is for that, or what the y component is. And that's what we're going to be doing. Another way to do it is to make a chart where you find your x's and your y's. Remember that x is going to be F31 times cosine of the angle, and y is going to be, so that would go here, and y is going to be F31 times the sine of the angle. So we have two steps here, right? We're going to have to find what F31 is, and then we're going to have to use cosine and sine to find the x and the y. We're going to have to find what F32 is, and in this case, F32 is not going to have any x, it's just going to be whatever that is, the y component. It only has one component. So let's do some numbers here. So let's say that Q3 is 4 microcoulombs and Q2 is 2 microcoulombs and Q1 is negative 2 microcoulombs. Now, the other thing we have to do in order to find F31 and F32 is we're going to need the distances between the charges. So let's just say this is 1 meter and this is 1 meter. We're also going to need to know the distance between Q3 and Q1. So you know that this is a right triangle, and we're going to have to use Pythagorean theorem to find that distance. So that would be r squared equals 1 squared plus 1 squared. So r is going to be equal to whatever the square root of 2 meters is. All right. So that's going to be our numbers. So the first thing I'm going to do is I'm going to concentrate on finding that vector that's at an angle and writing it in x and y notation. So to find F31, I'm going to take 8.99 e to the 9. I'm going to multiply it by 4e to the negative 6 coulombs and negative 2e to the negative 6 coulombs. And I'm just going to take the absolute value of that and divide it by the square root of 2 meters squared. When I start putting that in my calculator, it's going to look like this. 0.99 exponent 9 times 4 exponent negative 6 times 2 exponent negative 6. And notice I just dropped that negative because I want the absolute value of it, equals divided by the square root of 2 squared, which is 2. So this is going to be 3.596 e to the negative 2. 3. Now the next thing we have to do is we have to resolve this into its x and y components. So remember that this is a 45 degree triangle. How do I know that? Because the sides x and y are equal to each other. So this is 45 degrees, which means that this angle right here is also 45 degrees. If I didn't know what it was, then I would need to take my y and my x and find that angle right there, okay? And I would need to know what that angle is. And I'm going to have to do it by using a little bit of geometry to find those angles. So this angle right here, if I know what this angle is, then I know what this angle is. And that's the angle that I'm going to use to find cosine and sine. So f(31x) is going to be 3.596 e to the negative 2 times cosine of 45. And f(31y) is going to be negative 3.596 e to the negative 2 sine of 45. So let's do that in our calculator. Okay, let me just move this over. 3.596 exponent negative 2 times trig cosine 45. Oops. So my calculator is simple. It's a little backwards. So I'm going to have to do my trig first. I'm going to have to put 45 in here. And I'm going to have to take the cosine of it. And I'm going to multiply it by 3.596 exponent negative 2. That's going to give me, I'll just do it to 3 sig digs, 0.0254. 0.0254 newtons. Now it turns out that when you take the sine of 45, you get the same number. So this will be negative 0.0254 newtons. So I can write f(31) as 0.0254i minus 0.0254j newtons. Now, f(32) is going to be found. It'll be a little easier to find its x and y because it doesn't have an x. We're just going to use coulombs to find the value of the force, which is in the positive y direction. So f(32) is going to be 8.99 e to the 9 newtons meters squared all over coulombs times 4 e to the negative 6 times 2 e to the negative 6, these are both in coulombs, divided by the distance between them, which is 1 meter squared. So we put this in a calculator. 8.99 exponent 9 times 4 exponent negative 6 times 2 exponent negative 6 equals, divided by 1 squared, which is 0.0719 newtons. So remember, this is only pointing up in the So there is 0 in the I direction plus 0.0719 J newtons. So now, if I want to find the net force, I need to know its X and Y components. And to do that, I simply add all the X's together and all the Y's together. So F31 equals 0.0254I minus 0.0254J. F32 equals 0 plus 0.0719J. And F net is going to have an X component of 0.0254I. And this one is going to be 0.0719 minus 0.0254. So plus 0.0465 and these are both in newtons. That's my net. That's my X and that's my Y. And if I want to find the magnitude of that, right, I'm just going to say R squared equals 0.0254 squared plus 0.0465 squared and take the square root of it. And if I want to find the angle, and remember that that angle for this is up in the first quadrant, so we don't have to do anything to change it. It's going to be 0.0465 divided by 0.0254 is going to give us, if we take the inverse tan of that, it's going to give us our angle. So let's do that. 0.0254 squared plus the quantity 0.0465 squared in quantity equals square root 0.0529 or 0.0530, 0.0530 newtons. And then to find tan is going to be it's going to be 0.0465 divided by 0.0254 equals inverse second tan, 63.4 degrees. So F net is 0.0530 newtons at a heading of 63.4 degrees.